Okay, this is David I, and welcome to the Debug Tips and Tricks session, Effective Multi-Device App Debugging Strategies for Win32, Win64, OS X, iOS, and Android. And I'm here with members of the debugger and compiler team. Why don't you each introduce yourselves so that we can hear your voices and everybody can figure out who's talking as we move along.
This is Angel Martinez. I'm the QA debugger engineer.
This is Dawn Percick. I work on the compiler and debuggers.
This is Hento. I work on debugger.
Okay, excellent. And what we're going to do is we're going to talk and do a lot of demoing of debugging scenarios, and then feel free, everyone, to chime in with little tips and tricks, or don't do that, or do it this way, because debuggers are fun, mysterious, and also could cause issues if you do crazy things that you shouldn't do. We have lots of different debugger technologies in Red Studio 10 Seattle, different debug interfaces and debuggers for the different platforms. So I put this list here on the screen, grabbing it from the doc wiki, and I want to make sure, instead of just going through the whole list there, is about where the different pieces or parts of debugging are showing up. So depending on where you're running the IDE and what version of Windows that IDE is running on, and what type of platform application you're trying to debug, there'll be different things you'll need to do as a developer, both in configuring, setup, connecting devices, and so on. And I wanted to just put this up here. If there were any comments about, think of the IDE, or I think of the IDE as the sort of commanding interface for debugging. It has the different views that you see when you're debugging applications. It has the menu items that, in a sense, send commands to debuggers to do things, to get values, to set values, to stop at a breakpoint and bring back to the IDE. And I sometimes get confused about where is the debug kernel or the debug engine running. So in Win32 or Win64, we have our IDE, and what are we doing? Are we calling into the Windows operating system debug hooks? So the application is running in its memory space that applications run on. Where is the actual debug engine or debugger part? Is that in the operating system, in the platform, or is that something we provide?
The debugger kernel itself, in this case, we run in Windows, and then we do calling the Windows API to do debug stuff.
Okay. So what about for OS X?
OS X, the debugger engine itself, it runs in the Mac machine. So we're calling Mac API, OS X API. So the IDE talk to the Mac machine through the PA server.
And for iOS 32 or 64?
iOS 32, 64, the debug engine itself on the device itself.
Okay.
And then we, from the Mac, talking to the device using it as a protocol, and then we debug it that way.
And for Android, it's again in the device?
Android, the debug kernel is in the device, and then but the Android itself will live in the Windows machine. So yeah, the kernel in the device, so we just debug it that way. So
okay.
We don't need PA server.
So in all cases, we're leveraging an API into the different platforms to actually command debugging our applications, right?
That's correct.
Okay. Just to be clear, if our IDE runs as a 32-bit Windows application, and in Rad Studio 10 Seattle, now it's a large memory model Win32 IDE. And if I am running on a 64-bit version of Windows, my 32-bit Windows IDE, how does the 32-bit Windows IDE call or command the 64-bit debug kernel for debugging a 64-bit app?
So basically, the IDE itself, the debugger in this case will be running in the 64-bit mode. So IDE, the communication to this debugger kernel itself will be just normal channel thing that we talk to. And then the kernel that started will be 64-bit debugger kernel. And then that will talk using the Windows 64-bit API. So that's how we do it.
If I'm on a 64-bit Windows app running a 32-bit IDE, I can debug 64-bit Windows app on my same physical 64-bit Windows machine.
That's correct.
Or a remote 64-bit Windows machine.
That's correct.
Okay. All right. ultimately, it's all magic. The IDE can talk to all these platforms, devices, whether they're 32 or 64-bit, through the APIs, through kernels of the operating system, and all the magic happens when you want to debug your application.
Yeah, well, all these things we hide it from the user. As far as user concerned, you just hit debug; it will work for all the platform.
So next, I wanted to just make sure that everybody understands that there may be some work you need to do to set up your projects or your platform for debugging. And we have a tools options menu that allows you to set whatever debugger options you want as by default. It also will show you what registered debuggers the ID knows about in case someone else wanted to create a different debugger for some different kind of device or whatever. First, by default, integrated debugging is checked, turned on, so that you can do integrated versus debug from command lines, console apps, or whatever. Is there anything else to mention in sort of the settings? We have this notion of debug visualizers. We have documentation about how you can create your own debug visualizer. We have Angel, I'm not sure, but I think we give a sample debug visualizer. It may be like showing strings, for example, or a string list.
Correct, T-string list. And we also have a T-date time as well.
Okay.
Example.
And people can create their own. We have an API and there's documentation if you want to create your own custom debug visualizer for a data structure you have and so on.
Using the Open Tools API.
Yep.
Yes.
Okay. Just make sure you have the settings. Mostly when I do this work, I just use the default settings for debugging, and debugging works just fine. And then there's just a few slides here just to, again, orient ourselves to what's going on and where different pieces and parts are running. There's a separate code rage session that's diving deep into the PA server, the PA client, the PA server manager, and all of that. So we won't talk very much about PA server and all of its commands. We'll just see it in some of the demos. But when you're developing for a Windows application, everything is running on Windows. That's fine. When you want to debug a Mac OS X application, you have your development environment, and then you run this PA server, platform assistance server, on your Macintosh machine.
That's correct, yeah.
I have it running over here on my Macintosh. Here's the PA server for Rad Studio 10 Seattle. I also have another PA server for Rad Studio XE8. I have these desktop aliases to help me. You can always start with question mark, and you're set.
We recommend you use the PA server if you're doing any remote debugging from Windows, from one Windows machine to another Windows machine.
Right, so there's two installs for PA server. There's one for the Macintosh side, right?
Correct.
And then there's a Windows PA server that you can install. And I remember running that as a test. I had a I don't have a Win32 machine. I have all 64-bit machines now. So I created a VM of a 32-bit machine, and I put the platform assistance server over there. But you could also do remote debugging between VMs or two different 64-bit machines as well.
And it is a great way, an easy way to deploy files as well. If you just, you want to get your project over on another machine, make sure all the project files are included over. It's really good tool.
Okay. And then for iOS, there's the device, the iOS device. I've got my iPhone 6 connected through a USB cable, going through the platform assistance server, and then my development environment. And for Android, I've just got my Android Samsung Galaxy S4 connected through USB, and that's on my development system. So my Android device just shows up. There's nothing special I need to do in that respect. Well, I put this up here to see if there's anything special in preparing your project for debugging. There's the usual things of turning on, making sure you have debugging turned on, linker options, making sure your directories are set so you can find source code as you want to step through code, set version info so you might have information that's related to the certain build that you have. Is there anything else to think about? If I let me bring up the IDE. There's a Pascal project. Let's enable that. So if I go to project options for Delphi, there's I think I've just got my my paths, my output directories, compiling, linking. I think I've got debug information turned on, true. If I enable a C++ project, and go into project options. And now it's go into C++ compiler. I think enabling sections, RTTI, let's see, debugging. I've got debug information and debug line number information are on by default. Is there anything else special?
On the Delphi side, they're under the compiler. There are a couple of debug options as well. And I'd like to point out that if you are doing any remote Win32 debugging, you do need to include use or generate RSM, the remote symbol file for debugging, and that has to be included in your deployment. So by default for Win32, that is off because when you're doing local debugging, it's just all loaded in memory. But if you're doing a remote session, the debugger doesn't have that. So you need to generate that file and include it.
Is your suggestion you always leave it on for all your projects, or just
most people are doing Win32 debugging straight on the machine. So,
and for 64-bit, it looks like it's on by default.
Yes, 64-bit, it's always on.
Okay. I'm just going to put this up real fast. A couple things about debugger windows and commands, and we're going to switch to the IDE and take a look at a bunch of these different windows. Just under View Debug Windows, there's lots of different debug windows that you can bring on, including the CPU window, the floating point unit, the FPU window, and so on. So those are there. There's lots of different run commands. First, run with debugging versus run without debugging, which won't do any debugging. You can pass parameters if you need, if you're building console apps and other kinds of apps that are going to look for command line parameters. Then there's step over, trace into, trace the next source line, run to cursor if you point somewhere, run until return. If you've moved around, take me back to the current execution point. You can pause debugging. There's buttons on the command line. So there under the run menu, you'll find all sorts of commands for your debugging session. And some of them like F8, F7 have hotkeys that you can just sit there, step into, step over, and so on. And with that, let's go and spend the rest of our time in the IDE. Okay, so I've got different projects here in the IDE. These happen to be parallel programming projects. I have Delphi and C++ builder projects. Why don't we start with the C++ project? Again, under View, Debug Windows, we see the different debug windows. And then under when we're actually debugging, the CPU windows we can bring up as well. The other thing is under the layout, there is a debug layout that's chosen. You can create your own custom layouts. This is the default debug layout, which has a call stack, watch list, local variables wherever you are, event log, and then just your project menu. Again, you can customize your own debug layout if you want. So if we start with the default layout, and let's put a breakpoint, for example, in this method, which is on button 2, and make sure that I'm in the right programming language. Now, again, if you hit run, you're not going to do debugging. So everybody knows it's the run with debugging as opposed to run without debugging. You can also right mouse click in the project window and say run or run without debugging over here. So your choice. Or you can also hit F9, which is run with debugging versus shift control F9. So let's run with debugging. And let's go in and hit button 2. And now we're at a breakpoint. So we can see that the desktop layout has switched to the debug layout. And we can see some modules are being loaded. This is local variables, the self pointer, C++, we'd see this pointer. This is the call stack, how we got to this point. We don't have any watch variables right now. The other thing to note is for debugging, you can hover over the breakpoint you hit and see what condition happened. There's lots of debug options. You could right mouse click and bring up the breakpoint properties where you can set a condition. Is there anything special in either programming language about what kind of conditions, like a variable greater than 10, one variable less than another? Is there a limit to the kinds of conditions we can put there between Object Pascal or C++?
There's no limit. Just put any expression you want, so that should be okay.
We can also set a breakpoint in a specific thread. Here's a bunch of threads going on. I always get lost in how to identify what these threads are and what they might be doing. Is there any advice for developers?
If you name the thread, I believe that we perhaps show the name. But in any case, you can go to the thread view under message pane.
We were on the vet log. Here's breakpoint list. We have that one breakpoint. Here's the thread status. Okay.
Yeah, that will be the thread number that associated with the thread that show up in that list. So as you click on the thread, it will show you where the call stack is. If you name the thread itself, then you will be able to name associated with the thread number.
Okay. So like if I know this is my main application thread, for example?
You can name it, yeah. In Delphi, you can name it through your program itself to name the thread itself.
Okay. So I don't know what all these threads are. I'm not sure what they are.
Yeah, so if you click on it, look at the call stack, you'll know what's going on. But most of it will be the window thread, but some of them will be your program thread. It really depends on how many threads you have. So if you have a thread running, you pretty much be able to recognize them by seeing the call stack.
Okay.
Yeah, when you look at the call stack, you'll see if it's nothing that you're familiar with.
Yep.
I mean, not your code itself. That for sure will be OS thread, yeah.
While we're here, we're in our CPU view, and we're showing this is an entry point and some code. We've got the registers, the flags, and memory over here. You can do terrible things in CPU viewers if you want. You can go and change the values of registers. Like here's the instruction point. I could change.
Yeah, you really have to be careful because if you know what you're doing, that's okay. But if you change to be something else, that potentially might just crash your app. So it really depends on what you're doing. So
you can move the execution point.
Yeah, you can move the execution point, but sometimes you have to be careful because if the variable that you expect on the stack has not been pushed yet, when you do something else, potentially might mess up your code too. So
yeah, I think the only time I've done a new execution point is if I had a line of code in my own program that didn't have any real side effects that I didn't want to execute because I forgot to remove it, and I didn't want to go back and have to do a rebuild as I've been debugging along. I just wanted to skip an instruction, so I go down to the next source code statement that I trust doesn't skip any bad stuff and say, okay, start executing or stepping from that point.
Yeah, we also be able to do this from the source view side, from the editor side. So in this case, that's probably safer because that guarantee you to be from the beginning of the line, because one line can have a different instruction, and then you always want to skip into the complete instruction set for that line so that you're not in the middle of something.
So you're saying here, if I'm in the source code,
for example, here you can go to the I equal to 2.
Okay.
Move your mouse to I equal to 2, or mouse right click, and then you can say debug, select debug, and set to next statement.
Okay, just set
and
next
this
statement.
will be moved to the next line, bypassing the other 2 lines beforehand. So
okay.
That will be much safer it's kind of more complete.
And in this case, I feel comfortable. It's just not going to output 2 lines to my memo, and that's not going to cause tremendous havoc unless I have some other logic that relied on those 2 lines to be in the memo somehow.
You need to be careful there too, though, because sometimes lines can actually map to different address ranges. So, especially in our newer compilers that do some more optimizations. In the older classic compiler, you're safe doing this, but not so much in the newer compilers because they do a lot of more reordering.
Yep. And I remember seeing messages like when I tried to do a watch variable, for example, it would say the ID will tell me that doesn't exist. It was optimized out for some reason. So there's no variable to watch there. It might be in a register, or it may have been just removed completely, right?
Right.
And I remember years ago, we used to, when we were talking about debugging, when people weren't sure what was going on, sometimes we'd tell them, turn optimizations off, debug your application, then turn optimizations on and debug your application again. Is that still an advice for people who are trying to track down certain problems?
Well, actually, in the newer compilers, because debugging can be so, the debugging experience can be really bad under trying to debug optimized code, we actually don't support it.
Okay.
We don't support debugging of optimized code in the newer compilers.
Okay. I brought up before, but I'll bring it up again. Here's the floating point part of the processor. And so there's things you can, again, look and change flags, change values in the MMS registers and so on, that storage element. Modules view. What can we use the modules view for? I guess to see where debugging an application uses a DLL. For some reason, the DLL didn't get loaded. That might be one of the problems we're trying to track down. Is that what we'd use module view for?
In the module view, sometimes you might say, okay, before you debug your app, you say, I don't want to load the debug symbol for this particular module. Then you can, in the option of the project option, you can remove them all. And then as the module gets loaded, after you debug, you can say mouse right click to say, I want to reload this module again. Now the debug, if you do have debug symbol at this point, we will reload it again so you can see the debug symbol then.
Okay. There's a few right mouse click options in the module view. Break when the module gets loaded, so you can see, oh, it did get loaded. Angel?
Also, when I use it as a tool to check, like if I have a DLL and I'm debugging it, and for some reason it's not going into the code in the DLL, I'll check the modules view and just see if the symbol file was found.
And there's this here reload symbol table. It still has to have debug information. Is that right?
Yeah, reload symbol table. We'll try to reload your module, but if you don't have debug symbol, we won't do anything. But if you do, now suddenly this module will be reloaded again with the debug symbol.
And the way to tell if it has debug information is the little dots over in the side will be blue.
Like here, this is my app, which has debug information.
Right. Yeah, and you can see also the ones that are blue show the symbol file that's associated with it.
That's what you were talking about earlier, Angel, right? If you have RSM turn on for remote symbol names and so on. So again, breakpoint list, you can either right mouse click in your source code on a breakpoint, or you can right mouse click down here and go and enable, disable. You can get to the source code. So if you've been scrolling around in your code, you can do the breakpoint properties. You can add or delete or enable all. You can also build logic. Let's go back to breakpoint properties, because there's lots you can do here. For example, again, we talked about breaking in a thread or not setting a breakpoint in a thread. If you're doing a multi-threaded app where threads of the same code are being executed, and you want to find there's one specific that's causing some problem for some reason, you can say only break in that specific thread or a couple of threads and see what's going on. Pass count just means how many times. If you want to skip the breakpoint 100 times, 500 times, because it's happening on the 501th time or whatever, you don't want to be sitting there having to say continue, 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 and so on. You can set breakpoint groups. There's also this advanced button, again, which is there and not maybe for the faint of heart. I'm not sure. You can actually break, and this has been around for a while. You could say, we'll break on an exception. You can ignore subsequent exceptions. That's also an option when an exception is raised. You can tell the ID ignore that exception because I don't care about it, and it'll just keep going. Or handle subsequent exceptions. Whether you break or not, you can also log something in the event log. You can output the value of a variable or put a message on a breakpoint like, hey, I got to my DLL, everything is cool, whatever that might be. You can evaluate an expression, so maybe dump out a variable or x plus y, and you want to put that in the event log, for example. You can evaluate an expression. You can enable a group, disable a group, log the call stack, either the entire stack versus partial stack. Choose the number of frames. Okay, and the default is 5. Can I call methods inside of evaluate expression?
Yeah, you can, but sometimes some method, if they have a side effect of doing something like a stuck there, whatever, you might have some problems. So it really depends on if the function, for example, should be safe to call, but sometimes your function calling something else eventually might cause like a deadlock, whatever. So you have to be careful when you use a function call.
Yeah. We're at this breakpoint. And I think, Ken, you were telling me one thing here where I could bring up the debug window, for example,
go to CPU Windows,
yep.
Yeah, and then bring up the memory windows. Okay. The idea was, and then you say go to the address.
Go to the address of a variable like I. And then now we can step over the code, and there it executed our assignment statement. And so this little memory viewer is doing the right thing. And then if we go here, right, we see it in memory changing. It shows up in the local variables because I is a local variable, so I can see the value over here as well.
Yeah, so this is useful for you. For example, you want to know when this variable changed, and then so as you step the code, you know you have a bug because this value has been changed to something else. So, but you want to know where it changed, so you can do this way to figure out. So as we are here now, we can say set next statement.
So if I go put the cursor somewhere else.
Set next statement.
Okay, so that means now
Move.
at that point, it's moved the execution point. I can step along and do
That's
things
correct.
as well. We can see in memory here, it's a simple variable. This is an integer, or if it was C++, an int type. Is this memory view better for other types of variables besides just simple types?
Well, actually, this technique is good for if you want to watch a block of memory. But if all you wanted to do is just watch a simple variable, it's actually easier just to add it to the watch view itself.
Or if it's a local variable, it's already showing up in the local variable.
Right.
But we can right mouse click, go debug, and add watch wherever the cursor is, and now we see it up there as well. Yep.
Right. So that's an easier way to watch just simple things. But the memory view is great if you want to see what happens to a chunk of memory that's maybe getting overwritten, and you want to know when it's getting overwritten. You can step through and watch it change.
Okay. So if I did what? If I went in here and said go to self as a pointer, if something's happening to the instance, in this case of my form, for example, something's corrupting it, so I'd see something changing maybe somewhere in memory there.
Right.
The other thing you can do is you can expand in the local variables or watch variables or wherever you can expand and look at. We can also, here's a visualizer, right? We go over and visualize that. We could look at, here's the button instance and some of its fields, for example. We can go and look at those. Well, I guess memo might have a somewhere in the component might have a string list, for example, if we start splunking and drilling down. You can also inspect that variable, then it gives me the variable, and I can go in and even look and change its value. So there's lots we can do. Inspectors also allow us to walk down the tree of things. So if I say inspect this one, we now have another window, especially if you have like big monitors or multi-screens, you can start putting these memory and these inspectors. I like the inspector because it gives me the name in a nicer form. And again, I can scroll down and look at, here's everything that's involved in a form or a button and so on. See the methods and where they are. If there's specific properties, you can see the reader and writer, the value, and so on.
And also under the watch, you could right click and you get access to a bunch of different watch properties.
So here's watch properties. So again, it looks like I can change, like if I wanted I plus 10 or whatever.
Yeah, and you could disable allow side effects or...
Okay.
So if you wanted to watch a function call but didn't want it...
Do I use a visualizer if one is available? How many digits display? I can even look at it in a different type. I'm going to enable the C++ version of this same app. We'll go and look at it. And again, we'll set a breakpoint at the beginning and run with debugging. Here's a C++ version. This is using C++ Lambda functions up here anyway for using the parallel programming library, running of tasks, and then waiting in the background. And then it has an embedded Lambda for updating value of what's going on, the status of the thread running. So again, we can go in here and we have it as a watch window, and I guess I set it to hex, so it's showing me some strange value because it's an uninitialized variable. We can step over it. Now it gets a value of 0. We can bring up the memory window and go here and say, okay, go to address, in this case, %I, and there's that value in memory. We can step over and watch it change. We can go and look. Here's this pointer, so we can go and inspect this. And that's, again, for my form. We can dock it and put it somewhere and then drag it out as well. It also tells you what thread it's working on, that it's running in. So that thread ID is 5992. So here, let's go and choose our iOS 32-bit device. It's got my iPhone 6. And let's go and run with debugging. So there's the splash screen for my application showing up. And then the application that we saw in Windows will show up. It's got two buttons, the background task and the show value. So we'll go and tap on the show value button. If I switch back into the ID, it's hit the breakpoint. As we showed in Win32 and in Delphi, and well, we're in C++ Builder, and we did Win32. Now we're in iOS 32-bit. We've got the ID running on Windows. We've got the PA server running on my Mac, and now we've got the application running on my iOS 9 device, which is my iPhone 6, and we've hit a breakpoint. So the debug engine or kernel that's in the device has done its thing, and now I'm back in the ID, right? And I can do similar things, different things.
You can mostly do the same things, but like the you were showing the in the inspector about the data versus methods versus properties. Well, methods and properties aren't. Well, you won't see those.
Okay, but I can see the data, right? So I can see. I can go to my memo. I can go and change its value. Can I drill down? So I can inspect the memo. Okay, and now I'm going in, and there's and they have member data. So I can go in. I go debug Windows, memory, and the same thing. Go to address, and if I step. So what happened? That it's so magic.
So what happened will be the IDE send a command to the Mac machine through PA server, and then that PA server will send a command to the device to say, hey, give me the value of this particular address, then give it back to the PA server send it back to the IDE.
One last thing I wanted to note while we're in here debugging this iOS device application is that if we bring up the Debug Windows CPU view, you'll notice a difference here than what we saw before. Before we were debugging Windows apps, and it was the Intel processor with Intel registers and Intel instructions. Now we're debugging an ARM-based processor application, for example, on our iOS device. So you can take a look and see the CPU view again for this application, and the instructions look different. These are ARM instructions. These are the ARM registers, register 0. There's no flag registers. There's no strange named. Well, maybe there are strange name registers down below. There's a few of them. I guess the stack pointer and the PC or instruction pointer. So we can see those there. You can also resize these things and change the split if you're more interested in what's going on up in the register area. You can move around, and that's the same on whether it's an Intel processor or an ARM processor. This is the one way that I prove to our customers and developers when I'm giving presentations that we support ARM-based processors is I just put like a one-button app and a statement and set the breakpoint there and show the CPU viewer for Intel and the CPU viewer for ARM. Impress your friends, show them a CPU view dump of both targets, and they'll say, "Oh wow, it really can do multi-device development with multi-processors, Intel, ARM." So with that, I'm just going to bring up a few URLs here, and I'll make sure these slides are available. But you can just go to the Doc Wiki, and you can search on the Doc Wiki or hit help on any of the debug menu items and dialog boxes and project option settings and get local help in the IDE, or you can always go to the Doc Wiki. There's an index on the Doc Wiki for the debugging topics, how to use the debugger, preparing for debugging, how to use tooltips when you're hovering over your variables in the ID when you're in a debug session to see the values, adding watches and so on. There's also a bunch of see alsos that are there. So there's a lot of information available, the overview of the debugging process. There's even a whole separate section about debugging multi-device applications if you're going to be building Android, iOS, OS X, Windows apps using FireMonkey. So at this point, let's turn it over to your questions and see what kind of questions you have on the mysterious and rocket science world of debugging Windows and multi-device apps. Okay, I'm here in the C++ studio with Hen Boen.
Hi, Hen.
And Angel Martinez.
Hello.
And Dawn, who was with us earlier, she's off at the ISO C++ committee meeting in Hawaii. We're members of the ISO C++ standard committee, and go to the meetings and participate, just as when we talked with the C++ team earlier. We are involved in the whole Clang LLVM open source project and community and conferences. So we're very active in the world of the language C++, the libraries that surround it, licensing Dinkumware standard library, working with different platform vendors with their libraries, the Boost community, and so on. Okay, but this is all about debugging. So let me read some of the questions and comments. Will we ever use GDB for debugging Win32, Win64 apps? I know we use GDB on one of the targets, I think, or we integrate with.
We use GDB in the iOS 32 debugging.
Okay.
And for Linux using Android GDB, so
okay.
Linux only.
For
no,
Android.
no, Linux, I'm sorry. For Android.
For Android, right. Yeah. Got it. Well, think of Android as it's a subset of Linux, or it's a variant of Linux, so there you go. Ilya's saying CPU view is my favorite.
Okay, cool.
Well, in my days when I was younger, I did assembly language programming and machine programming. So my only world was, in a sense, the processor itself. I didn't have this exotic CPU view back in 1973 when I got out of college. But I still think, and taking compiler classes, when I look at source code, I'm always thinking it's other than optimized code of what's going on under the covers. And sometimes go to the CPU viewer just for fun to see what the compiler is doing. Enough of that. Which CPU instructions in CPU view are not yet being decoded? Do we have any instructions that don't show up somehow with the real mnemonics and all?
For all the platform, we do decode them already for all platform. Yeah. So if
okay.
anything that is not supposedly like a quote unquote not decoded, please let us know so we can look at it.
Yeah. Okay. So just go to, again, quality.embarcadero.com, log in with your EDN account, post a Jira entry,
yes,
create an issue. We use Jira for the public quality portal, and that gets migrated into the internal Jira we use, and the results get sent back to the public portal. So quality.embarcadero.com. If there's some instruction we're not decoding properly, or we're not yet decoding, yeah, please put that in there. What do you see when debugging on ARM? I think I showed the CPU viewer. You see the ARM registers, you see the ARM instructions, the flags, the memory.
Yeah.
Right. Yeah. So when you're in the IDE and you're doing watch variables, or you're doing stack traces or whatever, you're seeing the right things for whatever target. Is that correct?
Yeah, the stack trace will be whatever the stack trace for that particular platform. Yeah. So in the CPU view, the instructions will be for target platform. For example, ARM will be an ARM instruction set. Intel will be Intel instruction set. So.
Okay.
Break on load, cool thing. Oh, that was, I think, loading a module. Yeah, very cool. And all those different views, one of the things I always tell people, right mouse click. Right mouse click to see what's available, not just what's in our main menus or what's in the source code or what's on a breakpoint, what's down in event windows or whatever, but just everywhere. You know, right mouse click in the different panes of the CPU view, the memory views, and so on.
Yeah, they will have the subcontext menu in there,
yeah. What is add module for?
Okay,
is it add or load module, I guess?
Okay, basically the add, in the module view, you can add the module to say, in this particular module, when you want to, as it's loading, you want to hit a breakpoint to stop it as it load, or you want to reload them, this kind of stuff.
Okay. Are there any means for timing the loading of different modules in the app? I feel as our app has many BPLs, they're slow starting on the network because of some module or just their count. I know there's things like delay loading. At least in Delphi, you can delay load DLLs, or you can decide to load faster. I don't have any timings. You could use something like AQ time by SmartBear software or some other profile to...
The module, as the app loading it, then debugger get told, then we will show it to you. So in the sense that you can, there's no, for the debugger point of view, we don't control whether this module will be loaded or not, because if the app needed to load, it get loaded and we get notified. The only thing we control be when you load the module, whether you want to have debug symbol or not, that we control, that we can control whether we want to skip debug symbol or not.
So if you have lots of modules, I mean, they have to, lots of DLLs, I mean, they have to be loaded at some point in time.
Yeah. As the program loaded, your program call this DLL, it will load it automatically.
I guess you could instrument in code your different modules. I mean, that you have control over the source code. You could put a stopwatch timer, for example, and do something. CodeSite, you might use CodeSite Express to log the time externally if for the modules or DLLs or BPLs that you create. But the ones that you're using, that's based on what you're using of our runtime library of our components. These modules get pulled in for FireMonkey, VCL, RTL, and so on.
If the loading is the reason is because it's too slow to load, that maybe because you might want to say, I don't want to have the debug symbol get loaded first, and then at the end, after everything loaded, you can, for this particular module, I want to see debug symbol, you can reload them to add the debug symbol at that time.
I mean, when modules get loaded, you see them getting, if you say run with debug, you see the modules being loaded in the message window.
That's correct.
And I guess you would see them if you had the module viewer up, like on a different screen, you'd see them appearing.
I haven't tried that yet. I think we probably update on the fly, or maybe you have to refresh them. But from the message pane, as the module get loaded, we notify to the message pane immediately, and then we show them.
Yeah.
But the module view, I think you probably need to refresh them. I don't think we statically refresh them all the time.
Okay. Let's see. Oh, well, here's that question about, it's related to the optimizer. Why are there times when you can't watch a variable? I've done that, add a watch, and it just doesn't exist. It was optimized out. So it's put in a register. It's not in memory. It's not a memory variable. You could watch it in a register. You could put a register view up if you knew where it got put, but sometimes,
You mean like sometime when the code got optimized, the debug symbol for that thing disappear.
It's gone.
When you type it in, you don't see it.
You say right mouse click in the source code, add to watch window, and it says it doesn't exist. It's been optimized out.
It got optimized out.
Yeah. And so the only way I think we talked about that with Dawn, there's certain things where you have to just turn off the optimizer. If you're trying to debug it without optimizations turned on, where you get your code the way you told the compiler to have it. And then
default, the debugger, when you're in debug mode, it disables optimization.
Yeah. So there's certain cases, but if if you think something's going on with the optimizer doing something that's affecting your application, turn off optimizations, try to debug it, try to isolate what might be going on, then turn on optimizations, rebuild, and debug
after you're done.
If you can, yeah. And that's been the case since the early days of debuggers and optimizers. So would be great to save the list of watch variables and breakpoints between IDE sessions. I don't like to use a disk file for that.
I think indeed that's an option, like project
disk file. I mean, that's what he's saying. He doesn't like to use the disk file for that.
Oh. He wants to be able to save it to just any arbitrary file and load it from there, versus it going to the DSK file, the desktop file.
I see.
Yeah.
Okay.
Well, we'll pass that feature suggestion on to product management. Okay. How do you enable memory view when debugging? It's file. What is it? View debug memory.
Yeah, and the view debug, and then there will have the drop-down windows in there. I think under memory, right? Yeah. I think CPU view in that context. View debug, and then you can see something in there.
I think there's 4. You can have 4 different memory address views.
Yeah.
I think that's memory 1, 2, 3, 4. ARM CPU view, please. We have ARM CPU view. We showed it.
We do have, yeah.
Oh, maybe he wants a shortcut. Oh, Control-Alt-C. I don't know. Okay.
Control-Alt-C will bring up the CPU view, and then depending on what target you have, the ARM will show you ARM's instruction set. I think to like a memory view. few okay, go ahead.
Yeah, there's, again, it's under View, Debug Windows, CPU Windows, and then under there's Memory 1, 2, 3, 4, Control-Alt-E, Control-Alt-2, Control-Alt-3, Control-Alt-4. And then you can have a separate registers window, a stack window, a disassembly window, or you can have the entire CPU. So, and then the FPU is separate, modules, event log. Let me bring up the breakpoint view. And, oh, that was the call. Oh, it's down here somewhere. There it is. Breakpoint list. Yeah, there's a disable, enable, all. You can group breakpoints, but there's no right mouse click save down from in the breakpoint window. But again, I'll pass those suggestions along.
Okay.
As opposed to them being persisted in the DSK file. Okay. I don't know, is there tools APIs for getting at all the different views? If someone wanted to create a tool, I have to go back and look at tools. The tools API for the IDE, there's all sorts of APIs in there for doing things with editors and other parts of the IDE. I'm not sure about the debug windows and views, whether you could create your own IDE plugin. I have to go look. You might look at the tools IDE, tools API for the IDE, and see there may be an API you can call to hook your own, like saving and reloading functionality.
Yeah, we have to look at it.
Yeah. Okay. Let's see. Ken's asking, in Win32, what is the best way to inspect an item in an STL container, such as a vector at a particular index? I mean, you could put into the watch window the vector. You could inspect. You could right mouse click on the instance variable and say inspect, and then it would give you whatever it can do.
Of that thing, yeah.
Of that. So either inspect, right mouse click and inspect a variable, or you can put a variable in a watch window, right mouse click, inspect, and you can walk down pointer chains and so on using in the inspectors, expanding and follow. There's right mouse click. If it's an address pointer, right mouse click, and it will take you to where that points to. And if we have debug information about the structure, we'll display that. So check out the inspectors. They've been around for a long time.
Okay.
Inspect lets you look at them and see, depending on the target, see the fields, the methods, event handlers, and so on when it's Win32, and our BCC compiler versus the Clang enhanced compiler.
Okay.
But the inspectors let you walk all over the place, and you can have multiple inspection windows all over. You can put those on separate monitors while you're debugging, and all these CPU windows you can drag off, or you can dock them, and so on. So there's all of that available. You can see, and then there's a question about visualizing different types of collections like T-Dictionary and so on. We give you Debug Visualizers API where you can create and install. I think I showed that when you go to the Tools, Options, Debugging, and then there's a Visualizers that are installed. There's an API, and maybe you're suggesting that we add more standard visualizers for standard containers, for example.
Yeah, okay. Users can write their own too.
Yeah.
Using the Tools API.
Yeah, so under Tools, Options, Debugger Options, and then Visualizers, we have we talked about that T-date time, string, standard wide string, T-strings visualizer for Delphi. Those are the three that we built. That you might search for Rad Studio or Delphi or C++ Builder visualizers. Maybe some other people have built some that you can install, but there's an API so you can build your own. Because imagine you want to visualize an employee record in memory, like as a form, for example, where you would see, name, address, balance, and see it in a natural way versus looking at, you can always look at it as inspector. If we have debug symbols for the fields and their values, then the inspector would give you that kind of visualization when you inspect on an instance of a customer object, for example.
Yeah, we try to minimize, for the visualizer, you can add your own visualizer by yourself, but by default, we try to minimize as the visualizer not to have many of them, because otherwise, when you try to step over, we will try to use that visualizer to show you variables, and this potentially might slow down the debugging itself. So
yeah, if you don't want to add other plugins like the visualizers. Again, the inspector gives you quite a bit and lets you, expand if it's a class inside of it, expand it and see its fields and values. You can then, like I say, walk down pointer chains.
Walk down to that thing, and then when you hit step over, I think we automatically refresh them so you can't see them like that.
So if you have a T dictionary, something that's a T dictionary, inspect that variable.
Yeah.
You'll see the fields of a dictionary and how they're linked together, and you could walk down the inspectors.
Leave it open there, and then you hit step over your code, then you can see that.
Yep. As I mentioned, one of the things we don't do in this world is we don't undo. We imagine snapshotting all the side effects and all of memory. You can execute expressions that include method calls or function calls, and beware. We talked about that in the presentation that side effects can happen. Or if you skip over an instruction that's setting a pointer, you skip over that's setting a pointer, and then something's using that pointer.
Yeah, it might unpredictable results.
Yeah, unpredictable. So, but all those capabilities are there as you're debugging. When you spend a long time trying to find a problem, and all of a sudden you come to a point that you don't want to execute, skip over it. If you know what you're doing, what the app is doing. Otherwise, what do? You have to go in and patch bytes somehow, or rebuild, and then you got to get back to that point in time. So the debugger is there so that you can continue debugging as long as humanly possible, all those features, including changing a variable, a value in a register, or say a flag, because you know what's going on, or changing in memory, changing a variable in the watch, the evaluate modify box that you can bring up, where you can say, oh, I meant to have that variable initialized to 50. So bring up the evaluate modify, it'll tell you what the value is, change it to 50.
Change it right there, yeah.
So you can keep debugging as long as possible until you get to a point where finally you say, okay, time to fix all the things I found, go rebuild and start debugging again. Yeah. Okay. Int3, debugger, still working on x64. Int3 was always historically for breakpoints on Intel.
In Win32, yeah.
On Win30, on the Intel processor. I'm not sure about a break instruction opcode for ARM. I'd have to go look at the data handbook for the chip. It must have some break mechanism as well.
We have to look at it.
Yeah. But if you know, send me an email. If not, I can query to find the break character as well. Okay, well, those are all great questions. The whole world, there's probably books on debugging, the dark arts or the black arts, or the hacker's guide to debugging and so on out there. I know people have talked about that. There's so much that goes on in that world, from the days of putting a write-len or a printf in your code. And there's other ways of sort of capturing and debugging analytics, using app analytics, using CodeSite to log. Those are all part of the debugging process, or understanding what's going on in your applications beyond just the hardcore right to the metal debugging, and in the source code level debugging that the IDE provides. There's other tools out there, loggers like Eureka Log, CodeSite Express, which is built in CodeSite Studio, app analytics, where you can track. There's code coverage analysis tools. AQTime will do code coverage. SmartBear, you can go and look at that, and they support our compiled applications as long as you have debug info, where you can do code coverage analysis and all those kinds of things when you're, because I always would say the lines of code you don't debug or step through or execute through, unless you really know that they work. It's probably going to be some way some user is going to choose something that's going to trigger some logic that'll take you down a path that you haven't done. The other thing is we have audits and metrics. There are static analysis things that you can run. Those are under the view menu, audits and metrics for the language. And there's an audits command line tool that you can put as part of your build process. That might hint at some possible violation of best practices. So there's all those kinds of things that I always think about in the world of finding problems, as well as unit tests, doing unit tests. We have support for DUnit, DUnitX. And with that, Ilya's saying, have a nice rest of your debugging day.
Thank you.
Well, thank you, Hen, and thank you, Angel.
Thank you.
You're welcome.